Right, Form 5. Now, for natural environments, it's very easy to think about natural hazards, earthquakes, volcanoes, coasts, and rivers. But there are two other sections that could come up. One is weather, which we're going to look at now, and the other one is to do with kind of what do you call it? Um, Vegetation and stuff around, climate and vegetation. Let's share screen. Let's walk through the revision notes on collecting weather data. Okay. Now, just get that orientated. It's a quick revision, activate prior knowledge. Stevenson screens. If the weather does come up, bet your life that there'll be a 4 point question describing why it's designed the way it is. Okay, remember it's off the ground, 1.2 meters, because the ground reflects heat. You certainly don't put it on concrete, you put it on grass. You put it away from buildings and trees because they can affect with the weather. What do you put in there? Well, your thermometer is one of the things that goes in there. It's painted white to reflect the sun's rays. It's made from wood, a natural material. It has slats to create air movement. Okay. You take daily readings every day at the same time for consistency. Okay. You've got a thermometer in now, which is a sixes thermometer, which is the high and the low. Okay. Other instruments we find outside are the rain gauge for measuring rain in millimeters, the wind vane for wind direction, and an anerometer. Okay. Wind speed. The weather station, you've got barometers. All right. So they can go in the Stevenson screen. Let's have a look at this. It's a nice diagram of that. I don't want to spend too much time on it. We're not teaching here. We're just activating prior knowledge. Okay. Think of all those things. There's insulation in there as well, I think. Okay. Wooden box that avoids heat conduction, off the ground, reflected air movement. Okay. Now, examiner's trick and tip. You must know the difference between weather and climate. Climate is the daily atmospheric conditions. Climate is the long-term trend, minimum 30 years, okay? Very important, very important. Describe and explain the ideal location of a Stevenson screen. 5 mark question, okay? Away from buildings. That doesn't affect heat. Away from trees because they shadow. They affect the climate. On grass, so it doesn't. So it's not reflecting concrete. It's high off the ground. You don't want to put it in the middle of a public road because people will mess about with it. Okay. So let's be sensible. Wind direction, wind vane. Okay. The arrow points from the direction which the wind has come. In Mauritius, predominantly the southeast, the trade winds. Wind direction is also important for coasts, longshore drift. Okay. Right. Don't want to spend too long on wind speed, anerometer, miles or our point of view, kilometers per hour. Okay, the cup whizzes round, it rotates. Um, Handheld one. These might actually come up in paper four. Precipitation, rain gauge, millimeters. There are places where you should put rain gauges. You can't just dump them anywhere. Look, you bury them slightly, 30 centimeters above the ground, a bit exposed. But not at the same time, not again in direct sunlight because it will just evaporate it out. Okay, I'm not going to go into this in great detail. Temperature. So you've got the the average temperature, the highest temperature of the day. It's nearly 1 o'clock now. It's probably the highest today, but the lowest temperature of the day. You've got the highest and lowest on a monthly average, like on a climate graph. Okay. Remember the temperature range is that you minus the differences between, say your lowest is 20 and your highest is 30, the range is 10. Okay. Just remember those things. All worth points. Okay. Not going to go into that. 60s thermometer identifies the minimum temperature and the maximum temperature. Thermograph, we haven't really done those. Okay. The examiner's trips and tips. You could be asked to calculate a temperature range of events. For example, Lagos has a minimum temperature of 25 and a maximum of 35 for one day. You minus the 25 from the 35, and that's your range. Okay. Things like that. Always add the units to your answer as a habit. If we're talking centigrade, you say centigrade. If it's millimeters, you talk in millimeters. Humidity. Humidity is the amount of water vapor given, yeah, relative humidity, hygrometer. Okay. Again, it could be paper four. Air pressure. I'm not going to go through much of this. I want to get to some questions. Okay, this is just to remind you of stuff. Right, worked example. Name the weather recording instruments with each of the following features. What? See, tricky. They've spun it. So which instrument has cups? Well, it's the anerometer, okay, for the wind. What has a funnel? Could probably be the rain gauge. What has levers? Not sure what it means by that. I'll go back to that. Arrow. It's the wind vane. Corrugated metal chamber. Probably the Stevenson screen, isn't it? No, I don't know what that one is. The wick. Well, the wick we just saw. Let me just close that. Let's go back up quickly. The answers are there. Um, levers has. Come on, Mark, move it. Trying to move the screen up. Levers is the barometer or thermograph. That's the one we hadn't done much of. I think it's referring to those things there. The pen arm. Um, what else have we got? We mentioned the hygrometer. Let's go back. And a wick. Well, that was the hygrometer has a wick. The corrugated metal chamber I didn't know because we haven't really looked at an aneroid barometer. Okay. Sunshine hours, a Campbell Stokes. It's a big glass like fortune telling bell with a paper strip behind it. Every time the sun hits it, it will burn into that strip, which records the amount of sunlight you've got in a day. Okay. Not going to go into that. It looks like that. Clouds, cloud cover, octas. Octas are like fractions of cloud cover. 8 out of 8 is full cloud cover. 1 out of 8 is an eighth cloud cover. Okay. We did this on a previous revision for paper 2. Know your octas. Okay. Right, there you go. You've got an octa kind of screen. That's how you figure it out. Okay. And that you might see that kind of thing appear. Octa 4 is half. Octa 8 is full. Yeah, with no fractions shaded at all. It's a completely blue sky. All right, your different types of cloud, your cirrus, your cirrostratus, your cirrocumulus, outer stratus, outer cumulus, stratus. Remember, same names, different prefixes. Okay, and then your stratocumulus and your nimbocumulus, cumulonimbus, your kind of rain clouds. This is something you've looked at many times. You need to know it, guys. Remember, weather happens in. So let's tropical storms. Okay, what causes these? We looked at this Saffir-Simpson scale, wind speeds, when they can do damage. What causes tropical? We live in the tropics. What causes the formation of cyclones? We just entered the cyclone season. Okay, really got to revise that. Test your knowledge, and that's it. There. Let's go back down. Don't want to make the video too long. I'm just reminding you the the next part, calculations using weather data, could appear in paper two maybe, but you're just adding up the things, okay? Just working it out. You can do that without a great understanding of what they're doing. Okay, so we're going to kind of finish that one now. So it's a bit meaty for the day before the exam. Um, Again, interpreting weather data, climate graph. You should all be expert in climate graphs by now. You should be able to read various types of graph as the wind kind of rose, kind of, for which direction is the predominant wind or blowing, it's northeast. But you could describe a little bit more. You could, for 3 points, describe what's going on here. Okay, and you bring in more factors, talk about numbers, talk about directions. Okay, um, various isoline maps showing a bit like contour lines, areas of pressure. You could ask to describe that. That happens to be London, I can tell from the outline, okay? Now, synoptic charts maybe won't come up, but again, weather maps, areas like contour lines joining areas of equal pressure. Some Opta stuff, okay? Climate characteristics. See if I can get this in before I expire on time. Don't forget latitude, altitude, continentality, proximity to the oceans, prevailing winds are all factors that affect climate. You will probably get, if this turns up, a graph like this that will ask you to describe the distribution. 4 points for that. Talk about hemispheres. Talk about tropics, the line of the equator, name continents, north, south, east, and west. Use compass point directions. We have two things to look at, okay? One would be hot desert climate characteristics. They're one rainforest. Rainforests are wet. They're directly over the equator. Don't remember the Hadley cells as the warm air rises, etc., passes along to 30 degrees, sinks, And where that happens, we get the deserts. We have high pressure with no moisture. That creates deserts, that Hadley cell moving out from the equator. But the equator itself is, you know, very humid, very wet. Okay, that's why we have rainforests. There's a representation of what I was just trying to describe. You need to master that because that will almost certainly come up. Okay, I'm going to leave the video there because these can't be more than 10 minutes. But just a refresher, it's not teaching now.